Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4, Motion in a Plane. Today we are going to study about projectile motion part 2. In the previous class we studied equation for trajectory of a projectile, that is trajectory of a projectile is a parabola. Trajectory means the path followed by the projectile, and we derived an equation for trajectory of projectile. Then we studied three parameters of projectile motion, and they are maximum height, horizontal range and time of flight. So in the last class we studied only about maximum height. Now let us continue the remaining two parameters of projectile motion, and they are horizontal range and time of flight. Now we can study about the second parameter of projectile motion, and that is horizontal range, and this horizontal range is denoted by R. What is horizontal range? That is, the minimum horizontal distance travelled by the projectile is called horizontal range. Maximum height is all about maximum vertical distance. Horizontal range is about minimum horizontal distance. Right? Now we can derive an expression for horizontal range. For horizontal motion means we can take from O to, here I can write the final destiny as I can take here, this is Q. We can take from O to Q. Observe here, for horizontal distance from O to Q, right? The minimum horizontal distance traveled by the projectile is called horizontal range, or simply we can call it as range or horizontal range. Now first I am going to consider initial velocity. Initial velocity is resolved into two components. Along x-axis means we can take it as u cos theta. Then time is, we can take it as a time of flight, because time of flight means the time required by the projectile to travel from the point of projection to the ground. The total time taken by the projectile is time of flight. Let us take it as a capital T. Then the distance travelled by the projectile. Distance travelled by the projectile is equal to horizontal range R, because this is the distance travelled along the horizontal direction from O to Q. So we can take it as R. Then velocity. What is velocity? Rate of change of displacement. We can write displacement divided by time taken. So this equation we can use to find the horizontal range. Here I am going to substitute the value. Velocity is denoted by u cos theta is equal to displacement is along the horizontal axis. So we can take it as R divided by time is capital T. U cos theta equal to R divided by T, or we can write R equal to T into U cos theta. R equal to T into U cos theta. So here I am going to use the equation R equal to T U cos theta. Right? Now R equal to, what is a T? T is a time of flight. Time of flight is given by the equation 2u sin theta divided by g. Substitute here. This is the time of flight, 2u sin theta divided by g. Let us substitute here. Remaining is cos theta. Or this equation can be written as R equal to 2 into u square sin theta into cos theta divided by g. Or we can write here R equal to, I am going to write u square into bracket 2 sin theta into cos theta. 2 sin theta into cos theta. In mathematics you studied 2 sin theta into cos theta is equal to sine of 2 theta. This equation I am using here. So this equation becomes u square into sine of 2 theta divided by g. This is divided by g, here also divided by g. So we will get R equal to u square sine 2 theta divided by g. So this is the equation for horizontal range, or simply range r equal to u square sine 2 theta divided by g. Then the last parameter is time of flight. Time of flight means time taken by the projectile to travel from projection point to the hitting of the ground is called time of flight. You can observe this picture from O to, again it comes back to ground. We can take here O to Q. From O to Q, the time taken by the projectile to travel from point of projection to the hitting ground is called time of flight, or we can also define it as the time taken by the projectile to reach the same level of projection. To reach the same level means we are going to project the body from the point O from the ground. Again it comes back to the ground. From the ground to the ground, the time taken by the projectile is called time of flight, and it is denoted by capital T. Now let us derive an expression for time of flight. Yes, let us consider time of flight is capital T. What about initial velocity? Initial velocity, here I am going to consider u sine theta, because when we project a body, it starts to travel vertically upward. That is y-axis we have to consider. So the component of velocity is u sine theta. Then displacement. Here displacement S is equal to 0 because this is in vertical direction. For vertical direction, displacement is 0 because it is moving in the trajectory of projectile, that is parabola. Here it comes back to again the ground. For vertical direction, the displacement is 0. Then acceleration. Acceleration we can take A equal to minus g because it is vertically upward, exactly opposite to acceleration due to gravity. Substitute all the value in this equation. S equal to ut plus half at square. This is the suitable equation. Displacement is 0. U is initial velocity component. We can take u sine theta. Time of flight is capital T plus half. In place of A minus g we can write, and this is t square. Solving this equation, u sine theta t plus into minus will be minus half gt square. Or we can take minus half gt on the LHS side, it becomes plus half gt square is equal to u sine theta into t. One t will get cancelled. So we will get half gt is equal to u sine theta. Therefore, t equal to, we will get 2 will go to numerator, 2 u sine theta divided by g. So this is the expression for time of flight, that is 2u sine theta divided by g. So this is all about the parameters of projectile motion. The first one is maximum height, that is h equal to u square sine square theta divided by 2g. Second one is horizontal range, and the equation is given by r equal to u square sine 2 theta divided by g. Then third one, time of flight, and it is given by the equation t equal to 2u sine theta divided by g. So this is very important for numerical problems. Maximum height, horizontal range, and time of flight. These expressions are very important. Now let us study the next part, that is two angles of projection for the same range. You can observe here the projectile is projected at two angles. You can observe this diagram, theta and 90 minus theta. See here the angle between, you can observe here, this is horizontal and this is vertical direction. Angle between these two lines is how much? 90 degree. But how you are going to project the body in the space? We are going to project a body in vertical direction, or we can throw like this. You can observe here, we can throw a body in these directions. So that may be angle is theta, or it will be 90 minus theta, means less than 90 degree. We are going to project a body in the space. We are going to find two angles of projection for the same range, for the same horizontal range. When I am going to throw a body You can observe here, this is going to reach the same point A. It is the horizontal range or the direction. When I am going to throw, you can observe the first body is moving in this direction with velocity u. Because of acceleration due to gravity, it is moving vertically downward. Theta angle is how much? Theta. The second body I am going to throw in this direction. Angle between this projected body and this horizontal surface is theta here. Let us take it as u1 and this is u2. Observe here, we can throw a body or we can project a projectile at two angles. The first one is theta, second one is how much? 90 minus theta. Right? Now, you can observe here, the range of a projectile for an angle of projection theta is given by the range of a projectile. We already studied horizontal range. It is generally given by the equation r equal to u square sine 2 theta divided by g. This is the equation for horizontal range. The same horizontal range equation I am using here, but for angle theta, and the second one is 90 minus theta. Right? For the first condition, I am going to project a projectile with angle theta here. For angle theta, I am going to write horizontal range is denoted by r. So for the first body, I can take it as r1. r1 equal to u square sine 2 theta divided by g. Here angle is theta. Let us take it as equation number 1. For the second case, the range of the projectile for an angle of projection is how much? 90 minus theta, and it is given by 90 minus theta means we can use again the horizontal range equation, r equal to u square sine 2 theta divided by g, but in place of theta we should write 90 minus theta. Substitute here, r2 equal to u square sine 2 into 90 minus theta divided by g. In the first case, projecting angle is theta. In the second case, projecting angle is 90 minus theta. Or this equation can be written as r2 equal to u square by g. Keep as it is. Sine of 2 into 2 is multiplied to this bracket. 2 into 90 is 180. 2 into theta is 2 theta. Let us multiply 2. So we will get r2 equal to u square by g into sine of 180 minus 2 theta. We know that sine of 180 minus 2 theta is equal to how much? Sine 2 theta. You studied in mathematics, you can remember this equation. Sine of 180 minus 2 theta is equal to sine 2 theta. Substitute here. We will get range R2 is equal to u square sine 2 theta divided by g. Let us take it as equation 2. Now observe equation 1 and 2. Observe equation 1 and 2, both are same here. Angle may be theta or less than 90 degree, 90 minus theta, but horizontal range is the same, that is u square sine 2 theta divided by g. Then what is the conclusion? From equation 1 and 2, it is clear that the range of a projectile will be same for the two angles of projections theta and 90 minus theta. The range of projectile will be same. This means that the horizontal range is same whether the projectile is fired at an angle theta with horizontal or at an angle theta with vertical. You can observe this diagram. The first angle theta is taken with vertical. Then the second angle theta is taken with horizontal. You can take a projectile angle with respect to horizontal or vertical, but the horizontal range is the same for both the angles. Is it clear? So this is what? Two angles of projection for the same range. Right? So we will get the same equations. Then next one, relation between height and range of the projectile. Now we can find a relation between height and the range. Maximum height and horizontal range. Maximum height is denoted by h. Maximum horizontal range is denoted by r. Maximum height is h. Horizontal range is r. These are the parameters of projectile motion. Now let us find relation between range and the height. We already know the equation for maximum height and as well as horizontal range. Using these two equations, we can find a relation between them. Yes, we know that the maximum height is given by the equation u square sine square theta divided by 2g. U square sine square theta divided by 2g. This is maximum height equation we already studied. And horizontal range is given by the equation u square by g into sine 2 theta. Let us take it as equation number 2. Equation 1 gives maximum height. Equation 2 gives horizontal range. Let us divide equation 1 by equation 2. What is equation 1? Here I am going to write u square sine square theta divided by 2g, equation 1, divided by equation 2. Equation 2 means we can write g divided by u square sine 2 theta. Here u square will get cancelled. Remaining is what? G also get cancelled. Remaining is sine square theta divided by 2 sine of 2 theta. I wrote here. Observe here. H divided by R is equal to sine square theta divided by 2 into sine of 2 theta. Or this equation can be written as sine square theta can be written as sine theta into sine theta divided by 2 into sine of 2 theta. Sine of 2 theta is equal to 2 sine theta into cos theta. So in place of sine 2 theta, we can write 2 into sine theta into cos theta. Or we can take 1 by 4 outside. Here 1 sine will get cancelled. 1 by 4 into remaining is sine by cos. Sine by cos is tan. So we will get tan theta divided by 4. H divided by R equal to tan theta divided by 4. We want the relation between H and R. So I can write H equal to R by 4 tan theta. This is the relation between maximum height and horizontal range. We considered both the equations. Dividing equation 1 by 2, we got the final equation 3. Observe here, if theta equal to 45 degree, then equation 3 becomes. If theta equal to, in place of theta, if I am going to write theta equal to 45 degree, tan 45 is how much? 1. So we will get the answer H equal to R divided by 4. We know that H equal to R tan theta divided by 4. If theta equal to 45 degree, substitute here R tan 45 divided by 4, or we can write it R divided by 4 because tan 45 is equal to 1. So we got H equal to R by 4, or R maximum is equal to 4 times of H. Horizontal range is equal to 4 times of maximum height. So we can write maximum range is equal to 4 times of maximum height. Maximum range or horizontal range is equal to 4 times of maximum height, and this is the relation between maximum height and horizontal range, right? Then second one, equation of trajectory of projectile in terms of range. We already derived an equation for trajectory of a projectile. So that equation I am going to write in terms of horizontal range. Yes, first we have to write equation of trajectory. Equation of trajectory is, we already derived this equation 1. You can remember y equal to tan theta into minus of g divided by 2 u square cos square theta into x square. So this is the expression for equation of trajectory. It is of the form y equal to ax minus bx square. In place of a, we can write tan theta. In place of b, we can write g divided by 2 u square cos square theta. This is equation for trajectory. Then I am going to use horizontal range of projectile, and it is given by the equation r equal to u square by g into sine 2 theta. This is an equation for horizontal range. Now I am going to write equation 1, that is equation of trajectory in terms of range. Yes, Observe this equation here, r equal to u square by g into sine 2 theta. Here I am going to rewrite this equation. Observe carefully. R equal to u square by g, keep as it is, sine 2 theta. In place of sine 2 theta, we can write 2 sine theta into cos theta. So the equation becomes r equal to u square into 2 sine theta into cos theta divided by g. Or we can write this equation as, observe here, I am going to take r on RHS side, it will go to denominator. I am going to take g on LHS side, it will go to numerator, divided by 2 sine theta into cos theta. In that I am going to take 2u square on RHS side, it will go to denominator, 2u square. I am going to take only cos theta on the LHS side. So remaining is what here? Sin theta. I rewrite this equation, g by 2u square cos theta is equal to sin theta divided by r. Now let us divide by cos theta on both the sides. For this equation, let us divide cos theta. Dividing both sides by cos theta. See here, 1 by cos theta, 1 by cos theta. Let us divide here. So I am going to rewrite this equation. G divided by 2u square cos theta into cos theta is cos square theta is equal to sin by cos is tan. So tan theta divided by r. Let us take it as equation 2. Is it clear? Now this is equation 2. You can observe equation 1. G divided by this term b equal to what? G divided by 2u square cos square theta. In equation 1 you observed. Now you can observe equation 2. G divided by 2u square cos square theta, both are same. So in place of g by 2u square cos square theta, I am going to write tan theta divided by r. See here, the equation 1 is y equal to tan theta into x minus g divided by 2u square cos square theta into x square. I am going to rewrite this equation, tan theta into x keep as it is. In place of g divided by 2u square cos square theta, I can write tan theta divided by r into x square. Now we are going to express equation of trajectory in terms of horizontal range r. Equation 3 gives equation of trajectory of projectile motion in terms of horizontal range. So this is all about projectile motion. Remember, we studied what is projectile motion and some basic terms related to projectile motion. And then we studied trajectory of projectile is a parabola. We already proved it in the previous class. Then we studied 3 parameters of projectile motion: height, range and time of flight. We already derived each equations. Then we studied relation between horizontal range and maximum height. And also we derived equation of trajectory in terms of horizontal range. So this completes projectile motion. And the last part of this chapter is all about circular motion. So in the next class, we can study about circular motion.